Hi, my name is Ash. Welcome to this talk. We're going to be talking a lot about how Kotlin has changed Android. So our story is actually going to start with iOS, because iOS made a huge change from Kotlin, from Objective-C to Swift. And a lot of the changes that we see in iOS development is actually trickling over to changes in Android. So if we look, even knowing the graph on the right is showing that worldwide Android development is consuming everything. In the United States, iOS development is still almost 50% of the development and the customers. True that Android is globally much larger, but if you look at the number of dollars that are coming in, iOS is still pretty important. Now, if we look at iOS, we see that it made a huge difference when it went to Swift in the core language and how development works. And Swift UI made a huge difference in how the UI is built. In the same way, Kotlin is changing Android, and Jetpack Compose is completely changing the way that we do our UI. Now, everyone's learning from everybody, and I love this quote. It says, bad artists imitate, great artists steal. That was Pablo Picasso, and the guy who made this slide, he stole that from Pablo Picasso, and I think Steve Jobs stole that from him. And I'm going to steal it from everybody. So I'm going to say, I said that bad artists imitate and great artists steal. When we look at the very first phones that were coming out from Android, they looked exactly like the BlackBerry. So the Android team was working really hard to clone what the BlackBerry phones had until they saw the iOS. And then once they saw the iPhone, they said, you know what? We have to completely re-engineer everything we were doing to build the iPhone. Really shows that a lot of innovation does come from iOS, right? The iPhone hardware was the first one with the large screens. The Apple Store was first. The human interface guidelines were probably the beginning of the material design. They came out with dark theme, Xcode, and auto layout way before we had constraint layout. Swift was developed in isolation of Kotlin, but we saw Swift before we saw Kotlin. And then Swift UI is actually being used in production today, and Jetpack Compose is being released at a second point. And all of this was possible because of the client compiler. And the client compiler allows us to take C, C++, and Objective-C, Swift, and make machine code. So because of the client compiler, and because of Swift, iOS development has gone through a radical change. The same we're noticing is going to be true with Kotlin. So we can actually see the evolution of this new language. You can watch the entire Swift language being developed in Git, and every check-in is actually being recorded. And this allowed us to go from a very ugly language, which I like to call objective crap, to Swift. And here's just one example. The way that Objective-C did a closure is completely unreadable. And now, with Swift, closures follow the closure syntax, and the language really makes sense. It makes it really easy to intuit and think about how you want to write the language. And as Swift evolves and Swift UI evolves, the Swift language is also evolving. So that they've added opaque types, omitting the return keywords, they have functional builders and property wrappers. Everything here that we see in Swift 5.1, we also see happening in Kotlin, except for the property wrappers. So as the language is evolving, the platform is evolving. This is what Swift UI looks like with 5.1, with the property wrappers, opaque return types, trailing closures, and automated keywords. It's very easy to read, and it makes a lot of sense. You can almost read it like text. The black box is what it looks like before they made the language features. So my whole preference about this talk is that as Kotlin evolves, the Android architectural components are going to become cleaner, and the JetBrains team is working with the Android team to make Kotlin work better with Android. And we're going to see examples of that. So just like Swift gives iOS an ability to remove Objective-C, all of the NS code, and they're getting rid of UIKit. We're going to see that Kotlin's going to be able to do the same thing on the Android side. So if you were a Swift programmer before Swift UI, you were working Objective-C, you were working with NS code and UIKit. So you would have a storyboard, and you would put down views, and you would do control drag, and you do prepare for segue, do all this work to build your app. All that's gone. So that entire system with the storyboards and segues and all that, that's dead. It's gone. Now we have declarative programming. And what declarative programming does is it's one step higher than interpretive programming, because you kind of declare what you want. So you say, I want a menu. And if you're on a Mac, that's a pull-down menu. If you're on an iPhone, it's going to give you tab bars on the bottom. If you're on a watch, it turns into the crown. So declarative programming is a lot higher level of abstraction that we're normally used to programming, but it allows us to work across multiple devices with lots of different form factors. Now, declarative programming is new for iOS, and it's new for Android with Jetpack Compose, but it's definitely the future. And the reason it's the future is because we're getting so many different form factors. With foldables, if you take your phone and you fold it halfway, you're going to get like a keyboard, and if you're watching your video, you're going to get video controls. Now, this makes it really hard for a developer when we're thinking about where's up, where's down, what happens when I rotate the phone. Your constraints and trying to do this in a non-declarative way gets really, really confusing. But if you just say, I want a menu or I want a button, and let the operating system figure out how that's going to lay out for you, this is the way we want to go for it. So declarative programming is definitely the future of UI. Swift UI on the iOS side and Jetpack Compose on the Android side is how we're going to be building our views. And both of them, Swift UI is getting rid of Xcode and all of its views, and Jetpack Compose is getting rid of all the XML and the views that we're using today. So they're both complete new rewrites. Now, one of the things I really enjoy pointing out is I teach Swift and Kotlin, and I can teach them together, even knowing both languages were made in complete isolation. They have so many similarities. I can start with Kotlin, or I can start with Swift, and by the time I'm finished with one language, I can teach the other one almost in unison. So it's amazing, great minds think alike. Now, on the iOS side, we went from Objective-C right to Swift, and that was all work being done by Apple and the iOS team. But because Java runs on the JVM, lots of people were building languages for the JVM. And here's just a string of them with Scala, Groovy. One of the new ones is Kotlin. And it's wonderful to be able to choose so many different languages to run on the JVM. Languages really do matter. So on your left, you would see the languages that people love the most: Rust, Kotlin, Python, and then languages people love the least, and then the languages people really want to learn the most. And we'd see that Kotlin is very much liked, and everyone wants to learn it. So languages really do matter. The way I like to think about Kotlin is it's basically you take the book Effective Java and you take all the things that it has in there that says this is the right way to do Java, and you bake them into a language, and that's what you get with Kotlin. And if you look at Stack Overflow, you see how many people really get into situations where really they dislike languages and they start complaining about them. You hear very, very few people who are complaining about Kotlin. So language really helps out. Some of the features of Kotlin that make it so wonderful and allow us to write better Android apps are these. It's open source. It does higher order functional languages. So you can have a function that takes a function and returns a function. It has built-in null safety, which is wonderful. Extension functions, both Swift and Kotlin have this. So if you want to do something to a string, you can just write an extension function for it and just add that like the library already included it. Coroutines are first-class citizens, and they allow you to do parallelism. This is actually a link to a talk where Rob Pike, the guy who invented Go, talks about what's the difference between concurrency and parallelism. And you can think of it this way. Concurrency is like if you have one chef in a kitchen and he's doing multiple things. It's just one chef and he's just working across, maybe he's cooking and he's microwaving and he's mixing. That's concurrency. But if you have multiple chefs all working in different things and you have to coordinate all those chefs, that's parallelism. I personally, I understand when people talk about concurrency and parallelism. If they flip them, that's fine. But Rob Pike, the inventor of Go, he's like, okay, concurrency is one thing, parallelism is something else. So in Kotlin, there's no checked exceptions. And this is kind of controversial, but it kind of makes sense. Say you're writing a program. And in Java, what would happen is if you try to write to the disk and you have an inode problem that throws an exception, that's going to bubble up. So something's trying to write to a file, and it's going to throw an exception. The layer up doesn't know what to do with it, so it's going to throw an exception, and then it's going to bubble all the way up to the application layer. So now you have a banking application that is trying to do banking transactions, and it's getting an inode error. Why? Because Java is going to force you to handle all those exceptions and just throw them all the way up the stack. Kind of doesn't make sense if your banking application is trying to figure out what's coming from an exception that is being thrown by the disk. So Kotlin does not have checked exceptions. It has support for native delegation, and we're going to talk about that in a minute. It has default parameters, which make it really easy to work with, data classes, smart casts, primary and secondary constructors, wonderful interoperability with Java, amazing IDE support, solid design, fast evolution. One of the things I want to point out is doing iOS programming, you're going to spend a lot of time doing protocol-oriented programming. The way protocol-oriented programming works is instead of using inheritance, you're going to use these protocols to be able to have your objects gain functionality from other objects. Now, the reason that protocol-oriented programming works so well is that iOS has value types. Kotlin does not have value types yet. It was supposed to be in the JDK 10. At that point, Kotlin would have them, so we're still kind of waiting for Kotlin to get value types. So if you're learning iOS and you decide to do protocol-oriented programming, which I highly encourage because it's a much better way of doing programming, it's hard to do enough in Kotlin because there are no value types. I just wanted to throw that out. Now, in iOS, we do a lot of delegation. Kotlin also supports delegation, and this is coming from, we always wanted to instead of inheritance, we want to do composition. So composition over inheritance. Pretend I'm a library, and I have a whole bunch of books. And someone comes to me and says, oh, I want to be able to print your books. Well, as a library, I have really nothing to do with printing, right? I'm a library, I hold books. So the best thing to do is to use composition and then pass me an object that knows how to print. That way I don't have to, my library doesn't have to inherit from printing, which makes no sense. So here we have a derived class that is using this by keyword, and this is how delegation is done in Kotlin, so that when you instantiate the library, you're going to pass it an object that knows how to print, and when the library wants to print, they'll delegate that printing function over to an object that knows how to print it without having to break apart its inheritance chain. Another really wonderful property of Kotlin is we have coroutines, which make asynchronous programming much easier. And you can think of this as we're going to do a suspend and a resume every time we want to go off the main thread. So here we're going to have a call, and when we see the suspend keyword, it's going to go ahead and suspend the code routine at this point, move this onto a separate thread. It's going to resume execution, and and then when this thread finishes, it will resume that piece of execution. So what happens is, in this little bit of code, we can think of it sequentially, we can write it sequentially, we can debug it sequentially, but through compiler magic, it runs asynchronously. So we launch this, it suspends the coroutine, it puts it on another thread, that thread runs, we print hello. When this thread is done, it's going to resume, and it's going to print the word world. Where we really want to be starting to use this is for callbacks. And I just want to make this a little bit easier to read. I want to remind everyone that if we have a function and it has one of the parameters, is the last parameter is a closure, we can actually move it outside the parentheses. And if our function is only taking a closure, we can drop the parentheses. So we have a function here, and it's going to do a callback, and then usually what you would see is another callback, another callback, another callback, and you get into this callback hell. When you start seeing things like this, it's really a time to start using coroutines. Because in this code, I'm not even putting the exception handling, because any of these callbacks can fail and I have to be able to handle it. When I write it in coroutines, I can actually write it in like more of a sequential manner, and I can even put my exception handling in here, and the code stays extremely clean. But when it runs asynchronously. So you can think of coroutines as a one-for-one replacement for callbacks. Another thing they added, so not only does Kotlin support this wonderful thing of asynchronous programming, it now handles reactive programming with Kotlin Flow. And we're going to get a little deeper in how the Android team is using this. But you can think of the Kotlin Flow as, when you're doing reactive programming, it gets really difficult because you have to worry about the back pressure. But here with Kotlin Flow and the way that they actually use the suspend function in the coroutines is the compiler handles the back pressure for you, making it much easier to do reactive programming with Kotlin. Not only does Kotlin have all those amazing features I just talked about, but related to this conference, it runs on a lot of different platforms. And actually, at my work, we use Ktor with Expose to do our web. We use it on our native side, and we use different JVMs. So being multi-platform really gives us a lot of places where we can use our Kotlin code. So now that I gave a nice summary of what Kotlin can do, let's talk about how it's fundamentally changing Android development. Google came out and they said we are a Kotlin-first platform. And what does that actually mean? So for most of the platform, Java is supported. The place where it really changes is with the Ktx library, and I'll get into that a little bit deeper. They're going to do online training for Kotlin first, and their samples are going to be Kotlin, and they're going to do best efforts for the Java samples. Obviously, the multi-platform is not going to be supported on Java. And Jetpack Compose, which is going to be the future of how we build UI on Android, is not going to be supported on Java. And for me, what that basically says is we have to use Kotlin. Because when these foldables come out, these wearables come out, we're really going to have to think about declarative way of structuring our UI. So Jake Wharton in 2015, right, wrote a long article on why we should be using Kotlin for Android. But he is also working really hard to move Android to the JDK 9, 10, 11, 12. So there's still a lot of support being put into Java, but that's just to make the platform better when we write Kotlin. Now the Android framework has a lot of Kotlin components. It has the API annotations, it has the Ktx library, and coroutines have been put into the work manager, room, lifecycles, live data, view model, and Jetpack Compose. We're going to get into those a little deeper. One of the really, really nice things they did was Android Studio can take all of your Java code and convert it to Kotlin for you. In fact, I've seen people on the Android team write some Java code, have Android Studio convert it to Kotlin for them, to make sure that they're writing their Kotlin code properly. So when Android Studio is converting code from Java to Kotlin, it actually does an amazing job, and people use it to check how well they're writing their Kotlin. One of the things I have here on the block box is I'm showing Key Promoter. So you can go to Android Studio and you can go to the store and download Key Promoter for free. And what it does is every time you use the mouse to do a click, it shows you the keyboard shortcut for it. And I really encourage you guys to start using Key Promoter, because with Android Studio, the keyboard shortcuts are absolutely amazing. So definitely install Key Promoter and use that with Android Studio. Another real amazing tool they provided is Android Lint. Now, a lot of times when people go for interviews, they have this project that they take home and they code it up and then they send it back to the company as part of their interview process. I always want to remind people, run your Android Lint on the project that you're going to give back to the company, because the Lint system is really designed to do more false positives than false negatives. So it will analyze your code to make sure you're doing everything as the best to possible. But you have an ability to suspend the issues if you think it's giving you too many, and they would rather build it so it runs over a long time than miss any errors. It used to be focused on Android, but that's no longer true. Android Lint does an amazing job across any type of Kotlin programming that you're doing. Some of the features, it checks Java, Kotlin, XML, the Android manifest, the Gradle files, the class files, the pro files, the CFG files, the PNG files. It checks a lot of stuff for you. The static checker, 75% of the times, it can give you a quick fix. So not only is it going to tell you, oh, this is what's wrong, 75% of the time it says, click this and we're going to fix it for you. I think that number is a lot higher now. They've been putting a lot of effort into that. It has deep explanations of what Lint is describing as an error, which is really, really important. It runs on your continuous integration and deployment. And it has custom checks for the APIs. So again, Android Lint, I see a lot of people who are not really utilizing this as much as they should be. So I just wanted to call that out. Now, one of the things that we'll talk about is Android X. And people get Android X and Android KTX and Android Kotlin confused because they were released at the same time. But Android X has absolutely nothing to do with Kotlin. The reason that we have to have Android X is because the support library versioning systems were getting crazy. Sometimes you would use v4, before you would use v7 or v13, and then what was in version 14. Turns out that everyone knows what was in version 14 for the support libraries. Nothing. Basically, they had to have version 14 point back to version 4 because people didn't want to use version 4 because it was lower than version 13, but actually version 4 was higher than version 13. So they had to make version 14 so that, it just got so confusing. They said, okay, let's start all over with our naming systems, and they moved the libraries to the Android X naming system, and now you have these nice numbers that you can follow with 1.0, 1.2, 2.0, and the numbers are starting to make sense. Not only do the numbers make sense, but it's also fine-grained artifacts. So they took the support libraries and they butchered them into a whole bunch of different artifacts. So if you want to just update your cursor adapter or your custom view, you can do that without waiting for the next version of the support library. So the numbers now make sense, and they're fine-grained artifacts, so we can have rapid adoption, release and adoption. A part of the Android X naming system is Kotlin KTX, and Kotlin KTX is a different version of the artifact. It has the KTX at the end of it, and so you have the library, the support library in Java, and you have it in Kotlin, and you have it in KTX. So what's the difference? The KTX does not add anything to the Kotlin version. It only cleans up the calls. So there's nothing that the KTX library that does that's not in the Java library, that's not in the Kotlin library. All it is it cleans up the code. right? And it uses Kotlin-specific language features to make the calls cleaner. So on the light green you see what an original Kotlin call would look like. And with KTX, it's just a lot cleaner. And you see that all throughout the KTX libraries. It just makes it a lot easier to work with. They want to make sure that it has long-term use, it's a meaningful upgrade, and the intention of the extension is clear. And here's some links. This is a link to a talk that goes through the KTX libraries and a Medium posting that explains it. You can go and look at the artifacts and see how the KTX library is going to help you write better Kotlin code. You can click on what it would look like with Kotlin and then what it looks like with the Kotlin KTX extensions, and it's a lot cleaner. The problem is there's a discoverability problem. So I write this little bit of shared preferences here in Kotlin code. There happens to be a KTX version that makes it a lot easier to work with. But if I wrote this, how in the world would I know that I really should be doing this? Now, I could say, okay, I can come here, I can go to migrate to Android X, and then once I did that, it would update the KTX. That's not true. The migrating from Android to Android X namespace will not get you the KTX. So I actually opened an issue with the Android Studio team asking them to have a pull down where you could go, I want to convert my Java to Kotlin, I want to convert my namespace to Android X, and I want to convert my Kotlin to Kotlin KTX. So that's an issue I opened with them, and they're working on it, so hopefully in the future we can go just convert my code to Android KTX. Now the other way to find it is you have to watch the Twitter, because a lot of the Android team tweets out their favorite KTX extensions, and here's a link to 31 Days of Kotlin where they go through their favorite KTX extensions and how they're using them, because KTX really has a discoverability issue. I will be giving you guys at the end a link to these slides, so you can go and hit all those links up. Coroutines fundamentally changed how we do Android development. There were some very nice talks at Google I/O about how coroutines are being used by the Android team, and this slide shows you where we currently are. Work Manager has a coroutine work manager that is stable. Retrofit now can be suspended and it's stable. Room has suspend functions and they're stable. The view model scope, which we're going to talk about in a little bit, is stable. Live Data Builder, Lifecycle Scope, when started, are release candidates, and the Kotlin coroutine test is experimental, moving to release candidate, and will be stable in the future. So coroutines are fundamentally changing how we do Android development. If you look at Room, the way that Java would do it, we have our query to our database and say we want to insert a word here. Obviously, we can't insert this word on the main thread, and we would have to have a async task to move it off the main thread to be able to insert that word into our database. But because of Kotlin and coroutines, Room can now understand the suspend keyword. So again, we're able to think in a sequential way, we're able to program in a sequential way, we're able to debug in a sequential way, but in compiler magic, this is going to run asynchronously. And one of the nice things is that when you put suspend on Room, it knows that we don't want to write this on the main UI thread, so we say at thread worker, and then when we say suspend our insert word, it's done on a non-UI thread. It makes it much easier. And this is just one example of how Kotlin coroutines, and I'll talk about how Kotlin flow is used to make Android development much better. Again here, since retrofit 2.51 snapshot, we can use the suspend keyword inside retrofit, so we don't have to worry about doing all this nonsense of trying to get these network calls off of the UI thread. They're just taken care of for was. One of the other things that was an absolute nightmare was working with Bluetooth Low Energy. Now that Kotlin coroutines are here, we can easily call our connect to our GAS server. And again, we're thinking sequentially, we're writing sequentially, we're debugging sequentially through compiler magic. We're able to run this not on the main UI thread and generate a network thread. I don't know if you guys have done VLE programming on Android in the past. It's an absolute nightmare, but with coroutines, there's a lot of nice VLE libraries out there that you can use, and it just makes VLE programming much better. I talked to the Android core team, and they said they're not only seeing other people generating libraries for VLE, but they themselves are going to come out with a Kotlin coroutine VLE library that they're going to have as a part of the core Android. Now, this talk was given at the Dev Summit, I think a couple of weeks ago, and they talked about how coroutines and flow are being used with live data. I really encourage you guys to watch this talk. I don't have time to go through all of the details of what they talked about, but just some highlights. Now that we have coroutines, it's really easy to have our work done off the main thread. It removes boilerplate, but what it really does is it does structured concurrency and allows us to manage our jobs. You can think of this as a garbage collector for your view cycles, and they have these things called view model scope, so that when your view model's in scope, the activity is live, and when it goes out of scope, it's automatically cleaned up for you. So you can see they added the view model scope, the live data builder, the lifecycle scope, and when started. And all these are so that when you're working with live data, it helps you manage the jobs. And this talk gets a lot deeper into it. Another thing that they talk about is Kotlin Flow and live data. One of the really nice things about Kotlin Flow is that there are a lot of operations that you can do on Kotlin Flow. So the Android team provides a really nice call to, if you have a flow, Kotlin Flow, you can just say as live data. So you go to your data, you go to your data, and you get a flow from that data, and you can do all sorts of transformations on it, and then when you're done with the transformations, you can just say as live data and just use it as live data. It makes working with data just absolutely a pleasure, and Kotlin Flow is the key that allows this to work. And this talk gets into a lot more detail on how all that works. But again, coroutines allow you to do structured concurrency, helping you clean up your life cycles. Flow allows you to manipulate your data and then turn it back into live data. So really powerful. And all of this is coming because of the power that we're getting out of the Kotlin language. It's allowing the Android development team to really make Android development much better to work with. For a long time, I used to run around and tell people dependency injection is extremely important. If you're not using a dependency injector, I really encourage you to look at this thing called Koin. I used it for my dependency injector, but at the Dev Summit, the last Android Dev Summit, the Android team is talking a lot about Dagger 2. So no longer do I walk around saying, you should use dependency injection with Koin, changing my tune and saying you should use dependency injector with Dagger, because the Android team is working really, really hard to integrate Dagger in as the proper way to do object creation with Android. So when I teach Android now, I don't let anyone create objects unless they're doing it through dependency injection. Dependency injection is quite difficult, and to start a class with dependency injection because, well, they can't create any objects unless they use dependency injection, could be a lot to ask for. But as a part of the Android team, wholeheartedly embracing Dagger as the way that they're going to create objects, they've created this collab. And this collab goes through and it shows you how to use dependency injection in a fairly complex project. And after this collab, I have the confidence that I can teach dependency injection through this collab, and then my students will be able to use dependency injection when they start their projects. This really has to be the first step, because without a dependency injector, you can't make anything. So it's good that we have a less complex way to teach dependency injection as the first step to teach people how to become Android developers. Now, there was a lot of things that Android gained by all of the wonderful things that Kotlin is bringing, but I think the biggest is that Jetpack Compose. Like I said, declarative programming is going to be vital when we start doing very complex foldables and wearables, and we really want to be talking at a higher level. Now, this is a really nice tutorial to get people started with Jetpack Compose. When I started working with Jetpack Compose, I actually had to build it from the source. So I wrote a 3-part article on how you would go to the Android source, build Android, and then be able to run Compose and get an idea of how Compose works. The overarching idea of Compose is you kind of just tell the operating system how you want things to be and let the operating system figure out exactly how to do it. So here we're just basically saying, this is some code I wrote just to play around, but here I'm basically saying I want a row on the top with a little bit of padding, and then I want a row in the center in 3 more rows, and then I want a row on the bottom with some padding and there's some buttons. I laid out to the operating system what I kind of wanted and let it figure out where to put things. So if this was running on a watch, if it was running on a tablet, if it was running on a phone, if it was running on a wearable, if it was running on a foldable, it would always be doing the right things because I'm at a much higher level explaining what I want to be able to do. Coming from Swift UI, I really had a very good idea of how pieces should fit together. And if you go to Slack, following this link, you'll see the entire Jetpack Compose team talking in real time about how they're building Jetpack Compose. So if you have any questions about how does something work, how does navigation work, how does the recycler view work, or paging library, they're there 24/7, constantly answering questions, rethinking how Compose works, and they're doing it all live on this Slack channel. So I was talking on the Slack channel and I said, working on UI, I can see that Jetpack Compose is going to change everything. We're going to get rid of XML, we're going to get rid of constraint libraries, we're going to get rid of recycler view, we're going to get rid of paging review, and it's going to be replaced with composables. The view model is going to be extracted away, and navigation is going to turn into one line of code. So I posted that and I said, this is where I believe Jetpack Compose is going. And we will be able to tell over time if all this comes true. But if the Compose team is looking at what SwiftUI did, then this is the path they're going to be taking. And so far, a lot of it is coming true because recycler view is just a for loop. Paging library is going away. They're coming up with a new way to do view model. And if you want to go from one Compose to another, you just say navigate to, which is one line of Kotlin. So all navigation is just 14 characters. No more XML. Two-way data binding with the @ equals is all gone. So Jetpack Compose is a completely new way of building your UIs. Now, when I learned it, I had to go through the source code, right, and figure out by the source code how Jetpack Compose is working. I had to build it from the source code. You guys are super lucky. They have just released this tutorial that you can use to learn Jetpack Compose. You don't have to build Android Studio from source to be able to do this. Not only do they have this nice tutorial, they also have a code lab. right? So you can walk through this code lab. I wish I had this when I started. And you could go and learn Jetpack Compose. One of the things I'd like to point out in Code Lab is they have no navigation. So I think that navigate to go from one composable to another is not quite finalized. But they do talk about data flow. One of the things I will mention is that all data flows down, all events flow up, and it makes it much easier to intuit how your application is working. So again, you have a tutorial and you have a code lab that you can use to learn Jetpack Compose. So this is what Jetpack Compose looks like, right? It's very declarative. Basically, we're saying we want a column with a pictures followed by free text, and by just by putting this material theme here, it knows exactly how to lay it out on a watch, on a phone, on a tablet, or whatever device we're on. Now, what's interesting is they put material theme here. I wonder if one day in the future, if I could put the Apple hit here, if that would start looking like an iOS app. Kind of interesting. If I want to see, get a better understanding of the future of Jetpack Compose, I really do spend a lot of time looking at SwiftUI. SwiftUI, we're actually using SwiftUI in production code today. Jetpack Compose is being built it's being changed and built in real time. You can actually watch the Slack channels as the Jetpack Compose team starts thinking about different ways that they're going to build it. So I just want to end with some resources for you guys. So if you're new to Kotlin, here's a lot of links that will get you learning Kotlin, and then Kotlin on Android, some very good links to get you started there. Google, just very recently, took every single Android example source code they have and made a new URL. It's github/Android, and that's where all their Android samples are. If you're starting with a new project and you want to get deeper into Compose, you want to learn more about how Kotlin flows working with Android architectural components, you want to know how the new coroutine worker works, there's examples of all that inside these examples from Google. So it's just github.com/Android. If you only want to see the Kotlin ones, then add the language Kotlin and you'll see that. So they just brought all those together for us recently. That's a great resource. The code labs, they have one for Kotlin, Android. They have one for Jetpack Compose. The code labs are a really, really good place to start to learn anything that you feel like you're missing. Not only that, this link will take you to a whole bunch of Medium articles on Kotlin and Android. Not only that, but Udacity has a free class that covers pretty close to the latest stuff on Kotlin and Android. You know, it's like the alpha. It's like the latest releases. It's not really the most current, but it's a good start. It's absolutely free, and they talk about the Android architectural components with Kotlin, and maybe they're not up to the latest versions where they're using Flow or the new coroutines, but it's pretty close. It's as good as we're going to get for now. And then after you've learned all that, for a long time I didn't want to do the certification because the certification was only in Java, and for the last 3 years I've only been in Kotlin. So we're very glad that now you can do the certification in Kotlin using the Android architectural components. So that's wonderful. And if you want to follow me, I'm at Biocodes, and I have plenty of cards. If you guys want to grab a card, if you have any questions, I'm happy to take them. We have a couple minutes.
Yes, questions. I am going to grab a mic.
Hi, thanks for the talk. I was curious, there's a lot of things that seems to have come from SwiftUI into Kotlin and Android. Are there a lot of things that went the other way?
Yes.
Like we're taking more than giving back.
Yeah, no. So the way it worked was, at first, iOS came out, and they started doing lots and lots of innovative things. And then the Android team looked at a lot of that stuff, and it started flowing from a lot of great ideas from iOS into Android. And then what I noticed is Android really started accelerating a lot of amazing features that kind of made their way back into iOS. And now I think what we're seeing is they're co-evolving. So a lot of the ideas that came out of SwiftUI came from the React community, and the people who are writing Jetpack Compose actually were from that community. So there's a lot of, I think, co-pollination that's happening between the two. It's just that SwiftUI is already in production, and they've been doing it for 4 years, and the Compose team is still trying to figure out what all their APIs are. But I'm pretty sure as Compose comes out with some good ideas, we're going to start seeing them in SwiftUI. And I know that the Compose team is looking at SwiftUI, so I think there's going to be a lot of cross-pollination. It's just timing between who's pulling from who.
Any other? It went the wrong way.
Can you talk a little bit about the compatibility with the old versions of Android? Because SwiftUI you cannot use in the old systems.
Absolutely, absolutely. So because Kotlin runs on the JVM, right, and Android is just sitting on the JVM, there are a lot of features that you're going to be able to backport to very old versions of Android. And what you'll notice is that because we're now in the Android X namespace, they pulled apart those support libraries. And what they're doing is they're retroactively figuring out how they can get their current Android X libraries to be ported even farther back. So you can have some libraries, right? Because Android X fragmented everything out, right? So they're all little components now. You might be able to look at various pieces and say, okay, this goes way back, and this one goes way back, but this one doesn't. But I can not maybe use this, and then I can go even farther back, right? So because Kotlin goes to the JVM, I think you're going to see a lot, a big effort on the Android team to be able to go back to various versions of Android. Where with SwiftUI, you just can't do that because the latest version of Swift is sitting at 5.1, and that code needs SwiftUI, so only iOS 13 can do SwiftUI. Kotlin and Android and Java have none of those restrictions.
Yeah, I think in other countries outside the US, outside of North America, the older versions of Android are still really relevant and important. So it's a great thing that you can take your frameworks forward and still be able to run on those older models. So great, I think we finished on time. Any more? No? We're good?
I'll be around if you have questions.
Right on. And after lunch, we're going to have the lightning talks, GraphQL, Blockchain Kotlin, AR Core Intro, Women Tech Makers in GDG, and then I'm going to show you my bowstrings because I really like those. And I just want to show and tell and show a lot. So lunchtime, we've got some sandwich boxes from Panera. Ash, thank you so much. It's really great to have you here.